Hello students, welcome to my channel. Today in this section we will work out AC Verma's uh, concepts of physics chapter 2. Uh, its exercise problems, problem number 21, 22, 23, 24 and 25. So let's work out problem number 21. It says a curve is represented as y is equal to sin x. It is shown in this figure. Now, if x is changed from pi by 3 to pi by 3 plus pi by 100, which is a very small number, this quantity, find approximately the change in y. Now, here y is equal to sine x, therefore y plus delta y is equal to sine of x plus delta x. Therefore, delta y is equal to sine of x plus delta x minus y is equal to sine of x plus delta x minus sine of x, since y is equal to sine x. Now, in approximate case, we know sine x is equal to x. So we have the value of sine x plus delta x as x plus delta x, which is a pi by 3 plus delta x is pi by 100 minus sine pi by 3. Calculating, we get 0.0157. This is the answer. Next, we move on to question number 22. It says the electric current in a charging RC circuit is given by I equal to I naught e to the power minus t over RC. Here I0, RC are constant parameters, and we know that these are the uh, amplitude current, resistance, and capacitance, and t is time. Here we have to find the rate of change of current, that is di dt, at t is equal to 0, t is equal to RC, and t is equal to 10 RC. Now, given that I is equal to I0 e to the power minus t over RC, therefore, rate of change of current is di dt. Now, di dt is equal to dt of I0 e to the power minus t by RC, since it is the value of I. So, I0 is constant, so it gets out. So it becomes I0 dt of e to the power minus t by RC. And differentiating it, we get di dt is equal to minus I0 over RC e to the power minus t by RC. Now, when t is equal to 0, di dt is equal to minus I0 by RC e to the power, since t is equal to 0, it becomes e to the power 0, and e to the power 0 is equal to 1, so it becomes minus of I0 over RC. When t is equal to RC, just put it here, we get di dt is equal to minus I0 over RC into E. And when t is equal to 10 of RC, again putting this in similar way, we get di dt is equal to minus I0 over RC e to the power minus 10 RC over RC. RC gets cancelled out, and we get we are left with di dt is equal to minus I0 over RC into 1 over e to the power 10. Now, moving to question number 23, it says electric current in a discharging RC circuit is given by I is equal to I0 e to the power minus t by RC. Here, the value of I0, R, and C are given. I0 is 2 ampere, R is equal to 6 into 10 to the power 5 ohm, and C is equal to 0.5 microfarad, that is 0.5 into 10 to the power minus 6 farad. We have to find the current at t is equal to 0.3 second. We are also asked to find the rate of change of current at t is equal to 0.3 second, that is di dt at t is equal to 0.3 second, and find approximate value of the current at t is equal to 0.31 second. So let's tackle the first question. uh, I at t is equal to 0.3 second. It's very simple, just put the value of t is equal to 0.3 second here. Putting it, we get, and calculating, we get t is equal to, I is equal to 2 by e into a. Now didt at t is equal to 0.3 second. We have already calculated it that didt is equal to minus I0 by RC into e to the power minus t by RC in previous question. Now put t the value of t, that is 0.3 second, here, and calculating we get the final answer, which is 20, minus 20 by 3 e ampere per second. Now at t is equal to 0.31 second, I is equal, we are asked to find the value of I. Now we already have I at t is equal to 0.3 second is equal to 2a over e. So I is a function of time. Therefore, I at 0.3 second is equal to 2 by e into a. Now delta t is equal to 0.31 minus 0.3 second, which is 0.01 second. So when we have to calculate the approximate value, uh, we are uh, to go in such way. Just look at the solution. I at t is equal to 0.31 second is equal to I at t is equal to 0.3 second plus di dt at 0.3 second into delta t. Putting the values, we get 6 minus 0.2 by 3e ampere. Here a means ampere, and calculating we get 5.8 divided by 3 into e ampere. Every time I say a, it means ampere. Ampere. All right. You can take a screenshot of this. Now let's come to question number 24. It says find the area bounded under the curve y is equal to 3x square plus 6x plus 7 and the x-axis with ordinates x is equal to 5 and x is equal to 10. So finally we have to tackle this thing using the integration. Uh, so the previous ones are the differentiation problems and these are the integration problems. So the area under the curve, which is shown in this graph, is it. So this is given by a is equal to integration from x is equal to 5 to x is equal to 10 over y dx. Putting the value of y, we get integration x is equal to 5 to 10, 3x square plus 6x plus 7 dx. Integrating each term, we get 3 into x cube by 3 from 5 to 10 plus 6 into x squared over 2 from 5 to 10 plus 7x over 5 to 10 and square units, whatever the units will be of x, it will be square units because it is area. So calculating, we get 1000 plus 100 plus 35 square units is equal to 1135 square units. Here also you can take the screenshot of the rigorous calculations step by steps. All right. Now students, this is the last problems we are going to solve for today. Is the find the area enclosed by the curve y is equal to sin x and the x-axis between x is equal to 0 and x is equal to pi. So it is like the previous one. Area A is equal to integration x is equal to 0 to pi y dx. Now y is equal to sin x. So putting it, we get integration 0 to pi sin x dx. Now integrating it, we get is equal to minus cos x. X runs from 0 to pi in square units since it is the area, is equal to minus of cos pi minus cos 0 square units is equal to minus of cos pi is minus cos 0 minus cos 0 square units. Uh, so cos 0 is equal to 1. So inside it is minus 1, so it is minus 2, and outside the bracket there is another minus, so it will be uh, plus 2, that is 2 square units. So that's all for today. Thank you, students. Kindly like, share this video with your friends, and subscribe to this channel. Thank you.